Students, Namaskar. Students, we are taking some of the miscellaneous examples from the chapter matrices, and I have taken two examples based on principle of mathematical induction from the chapter matrices. This is the last question that I am taking from the chapter matrices and which is based on principle of mathematical induction. We will continue taking more example from chapter matrices, but this is the last example based on principle of mathematical induction. And after completing this particular example, I am sure you will have understood what is principle of mathematical induction and how to use it in the questions of matrices. So let us solve this particular question. Question is, for this square matrix A of order 2, we have to prove that A raised to the power n is equal to this, where n belongs to n. Dear students, I already told you in the previous questions that whenever we are given a statement which includes n and where n belongs to set of all of the natural numbers, then we have to use principle of mathematical induction to prove this type of statement. So here, using that, here I am writing the solution. Dear students, I am supposing let the given statement be Pn. Let the given statement be Pn. Okay, so the given statement Pn actually is A raised to the power n is equal to 1 plus 2n minus 4n and 1 minus 2n. This is the given statement. So students, the first step in the if you have to prove this particular statement using principle of mathematical induction is we have to check whether P1 is true or not. So finding P1, and LHS of P1 is A raised to the power 1 is equal to A only, and RHS of P1 put here in RHS of P1 n is equal to 1. So we do get 1 plus 2 is equal to 3, and then minus 4 multiplied by 1 is equal to minus 4, 1, and 1 minus 2 multiplied by 1 minus 2 is equal to minus 1. So I think it is equal to A only, so we can say this is equal to A. Hence we can say LHS of P1 is equal to RHS of P1, and that implies that P1 is true. So one step for proving this particular statement using principle of mathematical induction is over, and that is we have proved that we have got that P1 is true. Now students, the second step is, I am cleaning this. Now the second step is, we will suppose, here I can write step second. We will suppose let Pm be true. Let Pm be true. Dear students, what will be Pm if this is Pn? Pm will be A raised to the power m is equal to 1 plus 2m minus 4m m and 1 minus 2m. Okay, and I can give it equation number first. Okay, this is equation number first. Dear students, now using this Pm we have to prove Pm plus 1 true. So what will be LHS of Pm plus 1? I am taking LHS of Pm plus 1. What will be LHS of Pm plus 1? LHS of Pm plus 1 will be A raised to the power m plus 1, and that can be written as A raised to the power m times A. Let us put both the values which are let us put the value of A raised to the power m from equation number first, where we have supposed Pm true, and put the value of A from given value of A. So I am taking both of these values and writing them over here, students. This is equation number first we have given. So I can write putting the values of a raised to the power m and a from equation number first and given or question, you can say, respectively. So let us put both the values. First I am putting the value of a raised to the power m, that is available in equation number first. So here I am putting is equal to, the value of a raised to the power m is 1 plus 2m minus 4m, okay, m, and 1 minus 2m, and the value of a given is, what is the value of a given? 3 minus 4, 1 minus 1. 3 minus 4, 1 minus 1. 3 minus 4, 1 minus 1. We have put both of the values. Let us multiply both of these matrices. We will be getting a square matrix of the same order 2. First of all, this multiply by 3. So 3 multiply by 1 plus 2m and minus 4 multiply by 1, so minus 4m only. And the next, minus 4 multiply by 1 plus 2m, minus 4 multiply by 1 plus 2m, and minus 4m multiply by minus 1, so it will be plus 4m. Okay students, now the second row will be multiplied by the first column, so 3m plus 1 minus 2m, and now this multiplied by that, so minus 4m and minus 1 plus 2m is what we have got, is the matrix that has been obtained after multiplying both of these two matrices. Now this is equal to, we will be getting here 3 plus, what we will be getting, I am simplifying here, 3 plus 6m minus 4m. So we are getting 3 plus 2m is what we have got, students. Okay, here what we are getting, minus 4 minus 8m plus 4m, and that is equal to minus 4 minus 4m is the next element. Now the third element, 3m minus 2m is equal to m, and this is plus 1. Here minus 4m plus 2m is equal to minus 2m, and minus 1 is minus 1 only. Dear students, I would say this is equal to RHS of Pm plus 1. How it will be RHS of Pm plus 1? If students, if this is Pm or this is Pn, if you replace this n by m plus 1, then 1 plus 2 times m plus 1, and this side minus 4 times m plus 1, this side m plus 1, and here 1 minus 2 times m plus 1. What do you get? You get 1 plus 2m plus 1, so 2m plus 1 plus 2m plus 2, 1 plus 2m plus 2, it has been 2m plus 3. So yes, it is 2m plus 3. Okay, the next, minus 4m minus 4, minus 4m minus 4. The next here m plus 1, and 1 minus 2m minus 2. So minus 2m minus 1 is the next. So we can say the RHS of Pm plus 1 is actually this only. RHS of Pm plus 1 is this only. We took LHS of Pm plus 1. We used Pm here and proved that LHS of Pm plus 1 is equal to RHS of Pm plus 1 using this Pm true. So you can now write, since Pm implies that Pm plus 1 is true, Pm has implied that Pm plus 1 is true, therefore by principle of mathematical induction, the given statement is true. The given statement Pn is true, and that is what we have to prove, hence proved. I am sure you have understood this particular question. We have taken three three questions or three examples which are based on principle of mathematical induction, and they are from chapter matrices. I am sure now you can do each and every question of principle of mathematical induction from this particular chapter. Dear students, the next example that I am taking, the next miscellaneous example is, for what value of x the product of these three matrices is equal to a zero matrix. Okay, so to solve this, here I am writing the solution. Solution, students, we have to find the product of these three matrices and put it equal to the zero matrix. So first of all, what I am doing is I am writing the order of all these three matrices. So the order of the first matrix is 1 by 3, and the order of this one is 3 by 3, and the order of this particular matrix is 3 by 1. Dear students, first I will multiply both of these two matrices, and I will get a matrix of order what? 1 by 3. So here I am writing matrix of order 1 by 3, and that will be multiplied by this particular matrix, that is 0 to x, and its order is 3 by 1 is equal to a 0 matrix. Okay, so let us multiply both of these two matrices. First of all, this first row will be multiplied by the first column, 1 plus 4 5 plus 1 6, here the first element. The next one, 2 plus 0 is equal to 2 only, and the next one is 0 plus 2 plus 2, that is equal to 4, is what we have got, students. Now you can see the first row has been multiplied by the first column, 1 plus 4 5 plus 1 6 I have written here, then 2 plus 0, and then 0 plus 2 plus 2, and that is equal to 4 I have written here. Now when I multiply both of these two matrices, the next, what will be the order of this particular matrix? The order of this particular matrix will be 1 by 1. Okay, since both of these are equal, it means product of these two matrices is possible to find, and what will be the product? The product will be 1 by 1. So here I am writing a matrix of order 1 by 1. Only a single element I am to write, and that is equal to a 0 matrix of order 1 by 1. So multiply, first of all, 6 multiplied by 0 is equal to 0, plus 2 multiplied by 2 is equal to 4, and plus 4 multiplied by x is equal to 4x plus 4x. So dear students, what we have got here, we have got it is equal to 4 plus 4x is equal to 0, and this implies that 4 plus 4x is equal to 0, and implies that 4x is equal to minus 4, and that can be written as x is equal to minus 1. So for what value of x this particular equation is true? For x is equal to minus 1, this particular equation is true. So this type of question also you must be able to do, and this question is actually completely based on multiplication of matrices. So it is easy. For what value of x the product of these three matrices is equal to a 0 matrix. So first of all, I have found the product of these two matrices, that I have got this particular matrix, this has been put as it is. Now product of these two matrices is equal to this one, and that has been put equal to this 0 matrix. Eventually, since both of these two matrices are equal, so their corresponding elements are equal, so corresponding elements have been put equally, and then I have got x is equal to minus 1. So I am sure you have understood both of this particular example. Thank you.